Hello. So I'll be demonstrating my CI/CD pipeline made with Jenkins. So here you can see in Docker Desktop the containers that we have running. These are our more persistent containers. We have a kind control cluster and a Docker Compose list for our SonarQube server and for Jenkins. It also works in Docker Engine, by the way, and I'll be switching contexts later in the video and demonstrating that as well. But right now, for this test, we'll be running it on Docker Desktop. So we're going to be making a brand new pipeline, pulling it directly from GitHub. So tests, pull tests. Okay. So pull from SCM, which will be our GitHub. Put in our GitHub address. And then build the pipeline. So what we should see is different Java containers popping into existence and then disappearing. So first things first, a Java 17 container will be compiling in Java 17, we'll be running unit tests in Java 11, we'll be scanning on Java 8, building on Java 17, pushing Docker image, and all that good stuff. So you can see it just finished compiling, and now it's starting the unit test step in Java 11. We'll go through the pipeline code itself to confirm that's actually what's happening here. So here's our Jenkins file that's currently in use. So fairly standard stuff here. Check out the code. Defining the workspace here, this is where on the host the Jenkins data is. And we essentially just bind that everywhere that we need to access the data, like for the SonarQube scans and stuff. And you can see our different containers. We're using a Maven container because our package manager is Maven. Our Java project is written with Maven. Right? You can see 11, that's our unit tests. And for our SonarQube section, you can see that it is scanning on SonarQube 8. Have to use a older SonarQube image to make that work, but we make it work. And builds the jar, builds the Docker image in the jar, which is in the root of the repository, and pushes the Docker Hub and deploys our manifest, or deploys our Kubernetes manifests. It deploys our image essentially to a web app that we can access. So you can see there's a service.yaml and an ingress.yaml, so we can indeed access our app through web interface. There we go. Alright, so there is no UI, but there is full functionality. You see math local add a equals 5, b equals 20, you get 25. Change b to 40, you get 45. And it even resolves correctly if you attempt to divide by 0. That's subtract. It resolves to -1 instead of crashing, so very nice there. And now what we're going to do is we're going to stop everything on Docker Hub, and then we're going to run it on Docker Engine. So some of the scripts that are also in the GitHub repository are Docker Compose, kind config, kubectl, kind reset. What we can do is completely close down our pipeline section with our Docker Compose file. So Docker Compose the pipeline down. So it's stopping our Jenkins and our SonarQube container. You see it just stopped them. And now we're going to be using our kubectl command. That will close down our Kubernetes cluster. You can see nothing running here. So I'm going to exit Docker Desktop completely. I'm going to switch context to Docker Engine. I'm going to run the pipeline again. I'm going to continue explaining. So alright, and now we're going to restart our Docker. Alright, I started Docker there. Okay, so now we're going to bring everything back up and we're going to run it again. So, compose, I'm not going to name it anything, I'll say up. Oops. Stop that. Forgot the D, detached. Alright. servers are started, and reset kind. So this will reset our kind cluster. It will delete it if it exists, and then it will reset it with our correct information. It will set the port correctly, which was an issue previously, and we're just waiting for it to come up at this point. And then once this cluster is up, we will be checking our containers. So you see all of our containers are here and working. Our dev cluster, that's our kind cluster, Jenkins, and SonarQube server. So we'll reset Jenkins, or refresh Jenkins, log in again. And now, because we're on Docker Engine, it's a different workspace, so it's completely separate data we have access to. So let's pull another one. So engine test. We're going to be doing the exact same thing as before. GitHub project, git, save, apply, all that good stuff. And we're going to be building running our pipeline again. So, just some brief discussion on this pipeline. Here's the things it does: pulls the code, runs, tests, compiles in different Java containers, compiles, creates image and pushes it, deploys it to Kubernetes in a way that is accessible through our browser. Right here as we tested. And this is platform agnostic. It works on both Docker Desktop and Docker Engine. So one issue though is it does mount the Docker socket to the Jenkins container, which is a bit of a security issue. Essentially, anytime you have access to a Docker socket, you generally have root access to the host, unless Docker is specifically running rootless on the host. And the issue is that allows Jenkins, or a compromised Jenkins, to simply mount your entire file system to some lightweight container and then do whatever it wants with it, even in one scripted line. So the safest way to run this pipeline is on a Linux virtual machine, tested on the most recent LTS of Ubuntu. So it works great there. All you got to do is download your favorite Docker, either Engine or Desktop, download kind, and then apply all the configs from GitHub. There are additional scripts in GitHub that will help you automatically configure it for you. And you see here the whole pipeline completed successfully again in our Docker Engine in a completely different context. And I'm using a custom Jenkins image, by the way. This Jenkins image has a couple things I need installed on it. Specifically Docker, and you can see that most recent push, the push to Docker Hub part of our pipeline, that completed successfully 1 minute ago. So the app that we're actually working with here is the same one that's on our pipeline. And just a quick review of everything in the repository. So here are Kubernetes manifests all organized together, and the helpful scripts. Our Docker Compose, fairly simple, basically just 2 Docker run commands stitched together. This is for compatibility between Docker Engine and, so you can if you use Docker host or host Docker internal on Docker Engine, that will not resolve correctly. It only resolves correctly on Docker Desktop. So you can essentially add it as an extra host here through the host gateway. Then that lets you access it lets you resolve this URL on the host. And our SonarQube also has consistent storage. And let's check our test results actually. So projects analyzed, last analyzed at 6:03, so 3 minutes ago. 100% coverage, very good. Only a few lines of Java code. And that's essentially it. Now here, just for reference, is our app. So very simple little calculator. It's more about the pipeline, but either way, this is a fully functional CI/CD pipeline, platform agnostic. It can work in Docker Hub, which means it can work on Mac, Windows, or Linux, and it can also work on Docker Engine on Linux. So overall, fairly resilient, useful, and problem-free. Thank you.